Okay, thank you so much. Well, first of all, thank you, Professor Julio, and everybody for having Think Orbital today, and also Ellie for making the connection. I'll just do a quick introduction about who we are, and then we will be sharing. We will time it within the 15 minutes for sure. So my name is Sebastian. I'm the co-founder, co-CEO, and COO. And we have here today Wojtek Hulub, who is also co-founder, co-CEO, and also our Chief Technology Officer, and Elif, who actually is leading the architectural and interior design activities within Think Orbital. And what we will show today is the problem and the challenge we are working to solve. We will also showcase a video render of our method to have in-orbit assembly. And then we have a question for the audience and some sketches and some designs that Elif is going to take us through. So, if we can go to the next slide, Elif, and Boita, fire away. Thank you.
So imagine yourself in 5 years what will be happening, especially with the Starship development and enabling a lot of payload and potentially a lot of people being transported to orbit. Cost goes from $50 million per launch to conservatively to $500,000 per launch. A lot of people suddenly might have the opportunity and the ability to go to space. But what do you do there? In 5 years, all we have there is still International Space Station. So we believe that this kind of shifts the bottleneck from the launch industry from the launch to the infrastructure in space. And what we are trying to figure out here is how to create a large volume in space with a single launch that could be used for many different purposes, including a space hotel. And what we can show here, so we have time for the actual architectural discussion that Elif wants to introduce, is the video render. If
so
you can,
open the video render.
Yes. So this video shows how such a space station can be built and assembled in space. This one was designed for New Glenn 2 years ago, but you could imagine the same thing for Starship. So you have the second stage of the rocket launching the payload into orbit. The second stage is separating. And now that you have, there's the novelty that we offer, you have a flat packed, most of the space station is launched in a flat packed form, which can be assembled in space with a robotic arm. And that's where the novelty comes in the form of the robotic arm and combine it with so-called electron beam welding, which allows us to weld pressure vessels in space. And both technologies are proven. They could have been done 20 years ago. Robotic arm is on ISS, and electron beam welding has been tested by Russia and Soviet Union. So as the robotic arm starts picking up the pieces from the top of the stack, they are placed into their locations, temporarily latched together, and the robotic arm starts placing more and more segments in their respective locations. And as the segments, as there is more and more segments, all the hexagons are placed, and then there is the time for the pentagons, which are then inserted from the inside. And once this process of pre-assembly is done, everything is lined up together. The electron beam welding gun on the robotic arm can now start welding the individual seams together with airtight welds. And all this creates a huge pressurized volume in space. But this is where the challenge and opportunity comes in. And that is, how do you equip it? What would you do with the interior that is available? For example, for a space hotel, that's kind of the first use case we are exploring here. And of course, the volume is empty initially, so there has to be a few consecutive launches to actually fill in the interior. So this video showed how you could assemble a large habitable volume in space. And Sebastian, do you want to continue?
Yes, thank you so much, Boita. So before we jump over to the presentations, with the sketches and the work that Elif and Takashi are doing, other colleagues and friends who are actually helping to colonize, especially cislunar space. But the way we want to go about it, we've not seen it yet. So we think our solution is unique. at the pace we're growing now, we believe we can be first to market. We are looking at monetizing also the solution because, well, we also want to support our investors, the people that believe in us as well. So there has to be some sort of return on investment. The two technologies, like Boita was saying, they are tried and tested on their own. What we're trying to do, which is innovative, is bring them together, plus other technological evolutions as well that we won't have time to discuss today. It's cost effective. The majority of the ORB2, we want to produce it at scale. So we want to do mass production and have this so-called volumetric efficiency. And ultimately, it also serves as a platform. And why? Because it can be customized. The design itself can be adapted. There are some payload constraints, but ultimately what we want to do is to have a customer-centric delivery, something that can be utilized either for a private space hotel or also modified to be some sort of on-orbit servicing or even manufacturing. There's quite a number of use cases that, again, we won't have the time to go through today. So if we can go to the next slide. Thank you, Elif, if you can take it from here.
Yeah, thank you. So first I want to start with a question, actually. According to the video rendering you watched, I wanted to everyone make an interactive presentation to everyone, and everyone can open their voice and answer this question. If you could have a week holiday at our space hotel, what would you like to have there? Yeah, everyone can answer this question. Is there anyone?
Exotic view.
I can also read someone said spacewalk as well. Exotic view spacewalk.
What
So
about a moonwalk?
Why not?
Yeah.
We can see there's a lot of, we have, I mean, everyone at Think Orbital wants to go up there as well. So we also have a lot of wishes as well from our side.
Yeah.
Thank you for those that contributed.
Is there any more who wants to have something special at the space hotel?
Space aerobics.
Yeah, I'm listening. If there is no more comment, I would like to continue, and then in the end of the presentation, we will think about more. Yeah. So what we put on the interior design. Initially, we have thought the exterior of the wall. The whole sphere has been designed with some pentagons and hexagons. So according to these shapes, we placed some private rooms and technical area, management and medical and research area, service rooms, and other facilities. In the other facilities, there are greenhouses, entertaining area, food area, and gym area. And also at the middle, there will be like a Skylab floor. And here, first you can see the private rooms, how it is designed. As the hexagons has been cut in the middle, they could be 2 rooms for 2 rooms. So it's connected to the next pentagons. So the pentagons has been divided into 5 pieces, and each of it can be used for any other private room as a sanitary area. We have played on the pentagons and hexagons in different shapes, as cutting down from the middle and dividing down from the center, and combining them from the different corners, and opening and removing some walls, and just using in the free shape. We considered about having the ceiling and the floor as we have on the Earth. Here we can see the gym area. As you see that some walls are removed, so all the walls can be floor and can be ceiling in according to the requirement. In this area, we can see some circles and free area. It will be used for the recreational area with the greenery, because we are intending to grow up some plants, and it will make the recreational area like a cafe and eating area with greenery and having like a hobby gardens. In the zero gravity, as you know, there is no gravity, so we have to think about different concept of growing plant. So we have researched about Rota-Farm design, and we are trying to use them in a recreational area as here, and also having private places for greenhouse. And also this all around there is like a Skylab floor. So this is for free walking. As you can see here on the sketch, you will have a special shoes to have a walk like you have on the earth. And after that, in a center, as you can see here in a center, we will have like a management with the transparent area, and we'll be able to control all the around. And next to it, there will be like a medicine. And according to the urgent situation, will be like a medical area and research area. And from now, I gave some quick sketches and thoughts and ideas about the interior. So also, I would like to ask again if, if you could have a week holiday at our space hotel, what would you like to have there? If you have any other idea, I would like to put more, note down all the ideas you would like to have. And we would like to finish here.
Thank you, Elif, so much. Thank you also the audience. Yeah, this is the opening moment, and I can see somebody's putting experiments. And we know we have 2 minutes left for the 15 minutes. If we cannot field any questions right now, we can actually have your questions answered on the next slide. We have our contact details. And I understand, Professor Julio, if possible, we can share this with the audience as well, if anyone's interested to know more. But otherwise, yes, I give the floor back to Elif for the last minute and a half or 2 minutes we have. Thank you.
Yeah, actually, in the last 1-2 minutes, I would like to have questions to audience. So according to the presentation I did, do you have like addition, or you have an idea about any facilities should be moved or changed, or it will be, if you think it's a bad idea to having that there? I don't know. So just wanted to listen from audiences. I think they sent to chat box. Should I check the chat box?
In the chat post, we have had spacewalk experiments, also some kind words about the innovative concept, and congratulations, and also Julio thanking us as well, as we are running out of time.
Yes.
Yeah, we're 50 seconds to go.
Yeah.
So I think if no one has any more comments, if that's okay, Elif, we'll start wrapping it up.
Yes, okay. So we have finished here. Thank you for the inviting Professor Julio. Hope to meet another meeting with some more presentations and designs. Thank you.